Before we start the video, let me give you a brief introduction about myself. I'm Chandresh Mahajan, who is founder and chief educator at Exergic, which is India's most trusted and comprehensive institute for online gate preparation. I got an All India rank 37 from Gate Mechanical Engineering, and I am an ex Indian Oil officer, having 6+ years of teaching experience as of now. To know more about our GATE courses, you can contact us on these details. Also, you can download Exergic Gate Preparation app from Google Play Store. The link is available in the description of video. Okay, so before I start discussing this question, let me tell you that when you will complete this question, when I will completely explain this question, the learning that you will get from this question will not only be applicable in this question, in this unit, in this subject, but throughout the mechanical engineering. Wherever you will be having a cases of multiple equations and somewhat lengthy manipulation, this funda that I will tell in this question will definitely be helpful in those cases. So let us start this question. The weights of boxes A and B are 65 Newton and 130 Newton. In the diagram, you can see that there are two boxes A and B. Their weights is given as 65 Newton and 130 Newton respectively. Respectively. This is one word which is missing in the question. Okay. So block A weighs 65 Newton. Block B weighs 130 Newton. The coefficient of static friction between boxes A and between box B and floor is 0.2. Look, A and B have a common surface in contact, and B and floor also have a common surface in contact, right? Question has given that for the surface between A and B and for the surface between B and the floor, this is the floor. For both these surfaces, the coefficient of static friction is 0.12. Okay. What is the largest force F? This is the force F applied on box A towards the left side, for which boxes will not slip. Look, in this case, if I represent this force F which is being applied on a number line, okay, starting from 0 up to infinity, then when no force is being applied, obviously these boxes will not slip. They are just sitting where they are. But as you keep on applying the force F, as you keep on increasing the force F, what is going to happen? The block A will start developing a tendency to move towards the force F, right? So what you are doing, you are increasing the value of F from 0 towards infinity. A point will come, a point will reach F max when this force will be strong enough to move this block A into this direction. And that force, the question is asking you, what will be the largest force for which box will not slip? Largest force means in this range from 0 to F max, whatever value of force you apply, box is not going to slip. F max is the largest value of force for which block A is going to slip here. And obviously, if block A slips here, A and B are connected via pulley. So B will be slipping on the right side, right? They are connected via pulley. Let me tell you one more interesting thing about this question, which is 100% useful in every subject of mechanical engineering. It is asking you what is the largest force F for which boxes will not slip. This is the value of force. Largest force means in this region we are considering, this is the region that we are considering, and in this region this is the maximum force for which it is not going to slip. But the same statement can be written in a different form. It can ask you what is the minimum value of force F for which the box will start slipping. When I talk about minimum value of force for which box will start slipping, box will slip, it means that obviously if I apply a very high force, I apply a force 10 raised to the power 6 Newton, very high, 10 raised to the power 8 Newton, 10 raised to the power 80 Newton. such high imaginary value of force if I apply, obviously A is going to move. Obviously this force is so high that it will overcome the value of friction offered by this surface or by any other surfaces, right? But you cannot tell this as the answer, right? Question is not expecting you that you answer that 10 lakh newton is the answer. A random value of force is not expected. Question wants that you tell the minimum value of force for which the movement is going to start, right or not? This range tells the movement starts, and in this range no movement is existing because force is not high enough. This F max for this region is the maximum force, but the same F max for this region is the minimum force. So when we are talking about no movement, it will not slip, then force max is the largest one. But when the same statement will be formed and the question will say that what is the minimum force or what is the force for which boxes will slip or boxes will start slipping, then largest will be replaced by minimum or the least, because in this range F max is the least value of force for which movement starts. You got it? Trust me, when you will cover further subjects, I will discuss this concept with you in almost every subject, be it theory of machine, strength of material, fluid mechanics, machine design. In almost every subject, this funda is going to be useful, will be applied in solving numericals. Moving ahead, let me tell you one more interesting thing about similar question, that a similar question has been asked in GATE earlier. I'm saying similar. What is meant by similar? That one box sitting over another box, right? And some force is being applied to move them. Such kind of setup has been asked earlier, but obviously the setup was different. Force was being applied on the bottom box, top box was fixed with the wall like this, so that was a separate case. But if you understood this case that I'm going to explain to you, almost every question, every such question where there are two box setup, you will be able to solve. Obviously there are some good problems that you won't be able to solve even after understanding this question, so we will be discussing those in further examples, right? So one example is not enough, many examples we have to cover. So this example specifically will target such problems where you have one block on the top of other, and on one block force is being applied, and just we are discussing whether it is going to slip or it is going to not slip. Okay, in this question A and B are stacked over each other, force is applied on A and B are connected to each other. You can see that there is a string, a rope, which is connecting both of them together. This rope is passing over a pulley. This is a pulley over which it is passing, right? One more very small thing to note here is that this string here, no angle has been mentioned, so it will be assumed horizontal. But this string here is not horizontal, it is having a certain angle that is also given. It is making 20-degree with the horizontal. All right, now let us move ahead in the question and try to answer it. So far, let me tell you, we have not started the question yet, and this is something that you will notice in a lot of the examples that I solve, right? In course, you will notice that in many examples, almost every example, I spend at least, I'm telling you, 15 to 20% of time, total time of the session of the lesson, in explaining the question and understanding the question. What more can you learn from the question? Because it is one of the biggest mistakes that aspirants make. They don't read the question properly. They think that reading the question is a waste of time. It is not correct. You will suffer a lot if you think that reading question is a waste of time. There are many such small keywords. This is a small keyword here. This can totally change the game if question is appropriate, right? Not slip, not is a very important keyword. Even many small keywords can be placed in the question here and there. Obviously they are not present in this question, otherwise I would have explained them to you. But many small keywords can be placed in the question which can confuse you or which can lead you to the wrong answer. That is why I make sure that I spend enough time to explain the question to you, so that you also develop this habit. Because you will be seeing me solving hundreds of questions, and if you see that okay, sir is doing it, you will continuously see it. Indirectly it will be embedded in your mind that I have to read the question properly, understand the diagram properly, and then only I need to move ahead with the question. No matter how many times I tell you this, you will not get it until you learn it by observing my behavior, by observing how I am approaching the question. All right. Now let us start the question and try to solve it. And as I told you, something you will learn from this question which can be applied in every subject. Some of the things we have already discussed, a couple of things we have discussed which are applicable for other subjects also, but there is more to come. There's more to discuss in this question. Look, whenever you have such setup of multi body or more than one bodies, what we do, we draw the free body diagrams of them individually. If there is a single body, obviously we draw their free body diagram. But in such cases, when you have more than one bodies, we draw their free body diagram independently. So let us first try to draw the free body diagram of A and then the free body diagram of B. Okay, so this is the free body diagram of block A of box A. You can see that in addition to the force being applied, we have been given a weight of 65 Newton acting in the vertically downward direction. Since block B will also provide a normal reaction to the A in the vertically upward direction, so this is normal reaction provided to A, and tension T is acting not horizontally but an angle of 20 degree with respect to the horizontal. Are all the forces drawn in the diagram, or do we need to show something else? This force F is trying to move A. It's trying to move A. And whenever you have friction present, let me repeat this concept. This is a concept which I have told and covered in detail, but let me repeat it. Suppose you have a box, you have a block, and on that block, a force is being applied. We know what happens as a result of force. The body starts to accelerate. But you observed that the block is not moving, block is still at rest. Is it possible? 100%. Definitely it is possible. How? When the force applied will be totally balanced by the static friction. In that case, there will be no acceleration. The box will not move even when you are visibly applying a force, but indirectly or invisibly, the friction is acting between the box and the surface, right? So the question is asking you the largest force F for which the box will not slip. So it will not slip, it will be just at rest, just at rest. Any force, even slightly smaller than F, will start the motion of the block. Getting the point? So in this case, under the action of applied force, tension, and the static friction, this block will be at just rest. Just rest means any force slightly greater than F will start the motion, will start the slipping. So if we are applying the force in this direction, friction is going to act in the opposite direction of that to balance it, such that there is no movement of the block. And now the free body diagram is complete and we are going to start writing its equation. Applying summation fx is equal to 0 means every force which is trying to move on the right has to be equal to every force which is trying to move it towards the left. What are the forces that are trying to move it towards right? It is T cos 20. T cos 20, right? Plus friction, obviously. Let me write Fs as Fa here, right? Because we will be having friction in B also. And we are not talking about kinetic friction, only static friction is there. So let's not write S, let's only write Fa. It refers to static friction only. All right. So these are net forces trying to move towards right is equal to F, which is trying to move towards left. Equation number 1. Similarly, summation Fy is equal to 0 will give you that net force which is trying to move it upward, which is Na, should be equal to net force which is trying to move it in the downward direction, which is 65 plus T sine 20. Don't forget this. Plus T sine 20 degrees. You got that? These are the two equations that we have got from the condition of static equilibrium for A. Obviously, equation of moment is not useful. All the forces we are assuming that they pass from the center of mass, right? Now, moving ahead and drawing the free body diagram of the second body. Let's do it very quickly. This is the second body. The force tension is applied in this direction, right? No force acting on the left side directly. There will obviously be a normal reaction NB, and B is also providing normal reaction to A. Since A will receive a normal reaction in the upward direction, an equal and opposite reaction will be applied on B by the A. So NA is going to be in the downward direction. Simple. Getting the point? If you have A and B in contact like this, force of reaction on A will have to come in pair with the reaction, same reaction value which is applied on B. They are getting applied on the different bodies, Newton's third law of motion. So NA is present here in the downward direction. Now comes the friction. Okay, one more thing we forgot, the weight. Weight is going to act in the downward direction, which is 130 Newton. Now comes the friction. This surface as well as this surface are experiencing friction. That we know. That is easy. But what about the direction? Look, on block A, friction is acting in the downward direction. So on B, this FA will be acting in the opposite direction. Again, Newton's third law of motion. Between A and B, every force has to be balanced. If this is friction on A, then the reaction of that will be in the opposite direction. And this is the concept, similar concepts that we'll be thoroughly using in strength of materials. When you will be having one body connected to the other, you will be applying some force on one body, and then we will be drawing free body diagrams of them to find out the elongation and all those things. We will be discussing them in strength of material. So this concept will be used there also. Anyway, coming to the question. So FA, which was acting in this direction on block A, will be acting in this direction on block B. Equal and opposite and acting on different body. So FB will be acting in this direction. All right. One more surface is there, this one, block B and the floor. Now, where block B will tend to move, in the opposite direction of that, the friction will be applied. This force F is trying to move A in this direction. Since A is trying to move here, it is connected like this, B will try to move here, right? So B is trying or tending to move in this direction, which will be opposed by friction like this, by applying a friction in the opposite direction. So FB also, interestingly, is acting in the same direction as FA. All right, a small mistake by me. This is FA and not FB. This is FA, right? FA, FA, same in magnitude, opposite in direction, and on different bodies, right? Okay, so this is the free body diagram of block B. Did we miss something? Every force is considered. And now we are applying summation fx0, then summation fy0, and we will write two more equations for this. Applying summation fx0 will give you T is equal to fa plus fb, right? Similarly, in the vertical direction, it will give you nb, which is moving up, which is trying to move it up, will be balanced by na moving down plus 130. How many equations you have? 4. How many unknowns you have? T is unknown, FA unknown, capital F is unknown. And in this way, if you count all of them, you will see that you have 6 unknowns. If you count all of them, you will have 6 unknowns. 1, 2, 3, 4, 5 and F6. But in reality, there are 4 unknowns and not 6. And this is something which you should remember for every question of friction. In every question of friction, don't think that there normal reaction and the force of friction are unrelated, they are different. No, if normal reaction is n, friction is mu n. Mu is a constant, it is given to you. N is a variable which we have already counted. So force of friction is not a different variable. If you know the value of n, you know the value of friction. Mu is given to you in almost every question. That is why in this question, fa and fb separately are not different variables. Fa is equal to how much? Fa is equal to mu na. How much is mu? 0.12. Similarly, fb is equal to mu nb. How much is mu? 0.12. That is why fa can be written as mu na, and this can be written as mu nb. Mu will be common since mu is same. So this is the equation that we have. Mu, its value you can write, its value is 0.12, right? So 0.12, just a second. Okay, now you see how many unknowns you have. You have 4 unknowns: T, Na, Nb and F, which is required in the equation, which is unknown in the equation. And now 4 equations, 4 variables. The case is simple, it's not much difficult. But how to decide, that means how to solve 4 equations, 4 unknowns, that is interesting. Because I know that if number of unknowns are same as number of equations, you can solve them. But if I give you 100 equations with 100 unknowns, and if I ask you to solve them, you will not be able to do it. Because, or if you will be able to do it, you will take a lot of time. Because merely matching the unknowns with equation does not guarantee a quick solution, right? Or does not guarantee a easy solution. If you have 2 equation, 2 unknown, very easy. 3 equation, 3 unknown, very easy. But when you have 4 equation, 4 unknown, things start to get little bit complicated. And this is what I was referring to, will help you in every subject. Let me tell you how to decide here. Look, how many unknowns you have? F, let me use a different color for this. F, T, N, A and NB. These are 4 unknowns, right? Now let us talk about equations. How many equations do you have? In the first equation, this is first equation, this is second equation, this is third, and this is fourth. First equation means this one. How many variables are present here? T, F, A and F. So F, T, N, A I am writing. F, A means mu N, A. So you got the point? It is N, A rather than F, A. So these are the 3 variables. In the second one, you have N, A and you have T. In the third one, means this one, you have T and A and NB, right? You have T and A and NB. And in the fourth, you have NB and NA. NB and NA. These are the available variables in every equation. First equation has this, second this, third this, fourth this. And now when you're trying to solve the equation, this chart is going to help you. Some of the beginners will think that, sir, largest force F is required. We have 4 different equations present. Let us solve them simultaneously and we will get the answer. But let me tell you, 4 equation, 4 unknown can waste a lot of your time if you don't do it in the right way, in a planned way. Randomly, if you start solving them, it will take a lot of your time. So, in this case, what do you think? How should we proceed? Look, when you have 4 such equations, try to pick any 3 and try to make it a 3 equation, 3 unknown problem. You getting my point? Try to convert 4 equation, 4 unknown problem into a 3 equation, 3 unknown problem. And if you are able to solve it, obviously 3 values will be known to you. Only 1 value will be unknown, which you can easily calculate. In this case, if I ask you that tell me any 3 variables that I should pick in order to solve the questions, in order to solve the different variables, beginners may say that, sir, F must be in that variable. Try to pick FTNA or FTNB. But whatever you select, please select F also, because if we solve it, we will directly get the answer. But it is not possible in this question. Let me tell you why. If you include F, suppose you included F, T and NA, I'm just selecting a random number. First equation having these three variables, very good. Second equation has NA and T, very good. But third equation has now NB. Fourth also has NB. So you cannot write it as three equation, three unknown. You can only select two equations. As long as you entered third equation, fourth variable is coming, which is NB. You have to keep it three variable, three unknown, right or not? So you cannot select F, T and NA. And you can try other combinations also. It will not work. Why it will not work? Because F is available in very less equations. That is why, what is the use of drawing such a chart that I showed you? Try to select those variables which are present in maximum equation. Na present in all four equations. T present in three equations. B present in two equations. F is present in only one equation. That is why if you have to select three variables, T is on spot 1, Na is on spot 1, 4 in all four equations that is coming. T is on spot 2 in three equations that is coming. NB is on spot 3, two equations. In two equations it is coming. So these are the top three contenders for which we are going to solve the equation. And now let us see whether practically it is possible or not. First equation has F, that we are not considering right now. Second equation Na and T, right? This equation T, Na and NB. This equation NB and Na. All these three equations, this one and this one, have only three unknowns. Fourth unknown F is not present. And obviously these are three equations. Three equation, three unknown. Is it a difficult thing to solve? Absolutely not. You can very easily solve it. Let's solve that. Get the values of T and A and NB, and then we'll be able to solve the first equation also, because ultimately what we need the value of F capital F, for which T and Fa are required. So using these three equation, we will find out the value of T and Fa and then put it in the first one to find the value of F. Let us do that very quickly. This is equation 1, this equation 2, this is equation number 3, and this is equation number 4. Solving equation 2 and 3. Solving equation 2 and 3. Any two equations we have picked. What you will get? Basically, this equation of T we are going to put here. And that equation will be combination of equation 2 and equation 3. If you do that, you will get minus 0.958 Na plus 0.041 NB plus 65 is equal to 0. This is the equation that you have got. Let us name it equation number 5. And now we will include equation 4 and equation 5 to get the answer, right? This is how we solve three equation, three unknown problem. Include any two equation, frame a new equation combining both of them, and then solve that combined equation, which is equation number 5 here, with the third one, with the other equation. So that is what we are doing here. Equation number 4 and equation number 5 we are going to solve. And if you solve them, you will get the value of Na as, because in equation number 4 you have Na and B. Equation number 5 also has Na and B. If you solve them, you will get Na is equal to 76.6 Newton and Nb is equal to 206.6 Newton. Na and Nb both you have calculated, and since you have calculated Na and Nb, you have calculated Fa also, because Fa is nothing but mu times of Na, means 0.12 times of 76.6. It will come out to be 9.19 Newton. One more thing I would like to add here, since my focus here is not on doing the calculations, because this is a very easy question as far as calculations are concerned, but I have told this to you already that try to take up to 3 places of decimal. Okay, try to keep decimal values up to 3 places. In this question I am not doing it, but you know that in every question I tell you that. So 9.19 Newton. Similarly, FB is coming out to be 0.12 of NB, which is 206.6, and that will be equal to 24.74 Newton. You have calculated all the values. Last one is left, which is T. You know that T is equal to Fa plus Fb. Add both of them, you will get the value of T. And when you do that, you get the value of T as 33.93 Newton. And now nothing is left in the equation. T you have calculated, Fa you know. So this F needs to be calculated. Just put the value of T, put the value of F, cos 20, we can calculate. And that will give you the answer, the final answer for this question, which will come out to be 41.04 Newton. Let me tell you that my answer can slightly vary with yours because I want you to calculate exactly up to 3 places of decimal. There can be slight variation in the answer. That is not the case here. When we discuss calculative examples, then I tell you a lot more tips about calculations, about approximations. But this is not that question. Right now, focus was on other things. So, this is how you need to solve this question. And after this, any question you get when you have a block on other block, don't worry, don't panic, just apply the free body diagram for A and B, and you know what to do next.